Hello folks, in this video I'm going to talk about abstract data type. Okay. I think when we talk about abstraction, there are two different types of abstractions. One is process abstraction and the other one is data abstraction. So in programming languages, both process and data abstractions are the weapon we can use to attack the complexity of program. They can be used to simplify the programming process. It makes it easy for us to develop larger programs. Okay, so for the process abstraction, that's basically several programs, and for the data abstraction, that's basically abstract data type. So what is an abstract data type? Well, it's basically a user-defined data type that satisfies the following two conditions. Okay, the first one is basically information hiding. That means representation and implementation of objects of the type is hidden from the program units that use these objects. Okay, so basically, for example, if you want to define, let's say, a stack, okay, and what operations you want to define, and let's probably push something, right? You push something to the stack, and you probably have pop, okay, and you may have get size, okay, return the number of elements on the stack, and you probably have return a copy of the top elements on the stack. Okay, and what does this mean? That means if a program units want to use objects of stack, they do not need to know the implementation details. In other words, they don't need to know how these methods are implemented. By the way, these are the operations that you can use to manipulate the stack. Also, you don't need to know how the elements on the stack is stored or represented. Okay, as a user, you don't need to know these implementation details or representations. Okay, and this brings several benefits. Okay, it improves reliability. Why it can improve reliability? Well, in here, typically, it prevents you from accessing the data directly. If you want to manipulate the stack, you must manipulate through these provided methods. Okay, so every time you manipulate the stack through these provided methods, then these methods can enforce the rules. Okay, so in other words, if you push a value to the stack, you need to make sure there's a space on the stack. If you try to retrieve an element from the stack, they need to make sure the stack is empty. So these accessing rules can be enforced within these operations. If you can access elements on the stack directly without going through these operations, then these accessing rules probably cannot be enforced, and that will hurt the reliability. Okay. Another benefit is improved modularity. Okay. So that means in here, since you don't know the representation you don't know how the stack is stored, you don't know how this manipulation is implemented. So it is possible to change the representation of the stack or change the implementation of this method without any effect on the program units that use this project. So it makes it easy to modify the stack definition without changes on the user code. Okay, so that's improved modularity. For example, for the stack, well, sometimes it's probably array-based implementation, right? So you use an array to hold stack elements. But later you think array is not flexible. You want to use linked list. Well, that's fine. If you change it, then there's no effect on the program units that use this stack, as long as the signature of these operations are not changed. Okay. The ADT, because of the information hiding, it introduced a new scope. Okay, so you can define some member data in the stack. Okay, so for example, size. Okay, you probably have something to track the number of elements on a stack. You'll probably have another one to represent the maximum number of elements allowed in a stack, or you probably have something to hold elements in the stack. Okay, so the ADT, the information hiding, they introduce a new scope. So these variables, that's fine. Okay, and outside of the ADT, you can reuse the size, so there's no name conflict. Okay, so basically, it eliminates the chance to use global variables. Okay, and also it reduces the probability of name conflicts. Okay, so this is one condition. The second condition, the declaration of the type and the protocols of the operations on objects of the type are contained in a single syntactic unit. Okay, so basically the signature of these operations as well as the member data and the declaration of the ADT is contained in one single syntactic unit. And in most program languages, that's basically class. Okay, that's basically class. There are some benefits. So it makes it easy to manage these data types because it's containing one syntactic unit. So you just need to manage these different syntactic units. It makes it possible for the separate combination. So if you develop one abstract data type, you can just compile it. Okay, so if you have multiple abstract data types, you can compile them one by one, and later you can integrate them together. Okay, so separate combination. It will also make it easy to share among different programs because everything is in one syntactic unit. So you only need to share the syntactic unit by itself. That should be fine. Okay, so these are the definition of abstract data types. Next, let's talk about constructors and destructors. Okay. Constructor is basically a special method of a class, okay, which is used to initialize an object of the type before it can be accessed by other program units. Okay, remember, constructor is not used to create a new object. It's used to initialize a newly created object. Okay, so in other words, whenever you access the object, that object is guaranteed to be initialized by some constructors. Okay, and typically here are some properties related with constructor. I mean, typically you may have multiple constructors. So in other words, you can initialize objects in different ways. Okay, or you probably can provide different information to initialize the object. Okay. The name of the constructor is predefined. In most program languages, the name of the constructor is class name. In some other program language, I think it's in Ruby, the name is initialized. Okay, so it's predefined. You have no freedom for naming constructors. Okay. By the way, if you have multiple constructors, the parameter list must be different. In other words, they must be overloaded constructors. Each class must have a constructor. This constructor may be provided by programmer explicitly or may be generated by programmer. But no matter what, each class must have a constructor. Okay. Typically, the responsibility of the constructor is to initialize data of the object of the type. Okay, other than anything else, you should not put it in the constructor. You should put it in somewhere else. For example, establish the connection to a database, then you probably don't want to put in the constructor. Okay. And the constructor has no return value. Okay. So if something happens, if something is wrong, what shall I do? Well, if that's the case, you probably want to throw exception to indicate that something is wrong. For example, within the constructor, you need to allocate a big chunk of memory space to hold values. But if that allocation fails, then you probably want to throw exception to notify the users of this class. Okay. So this is constructor. Next is destructor. Destructor is also a special method that gets called automatically as soon as the life cycle of objects it's finished. Okay, so in other words, destructor will be called automatically whenever an object to be destroyed. Okay, either that object is out of scope or that object is destroyed explicitly by programmers using built-in functions or, for example, delete operators in C++. Okay, the main job of the destructor is to release resources occupied by the object. Okay, so the object that's going to be destroyed may have some resources. For example, it opened a file, it has a database connection or network connection. So before destroying the object, we want to release or disconnect from the database, disconnect from network drive, and close the file. So that's the things we want to do in the destructor. Okay. Typically, there is one and only one destructor. You cannot define multiple destructors. And the destructor, no parameters allowed. Okay, no parameters allowed, no return value. So there's no return value for the constructor, even void. Okay, and similar to the constructor, if something is wrong in the destructor, you'll probably want to throw exception. Similar to the constructor, you have no choice on the name of the destructor. Typically, the name of the destructor is always tilde followed by the name of the class. Okay, so next one. So for example, I can create a stack. Okay, so in here, this is the syntax we use in C++. So this is the name of the object and followed by an argument list. This argument list will be used to decide which constructor will be used to initialize this new object. Okay, and for the destructor, you never call the destructor explicitly. Okay, you as a programmer never call the destructor explicitly. The destructor is called by the system when the object is going to be destroyed, for example, out of scope. Okay. So this is constructor and destructors. By the way, for destructors, in some program language, I should say not all program languages provide destructor, especially for program languages that use garbage connection. Like Java, like Ruby, they do not provide, well, I should say you don't need to define destructors in such program languages, okay? Because they use garbage connection to manage objects. And in C#, C# also use garbage connection. And when an object is marked as garbage and to be recycled, in that case, the destructor is called. So in that case, you have no idea when the destructor will be called. Okay. Let's take a look at the design issues of abstract data type. The first one is, what's the form of the container for the interface to the type? In other words, what's the syntactic unit we use to contain the definition of the ADT? In most program languages, that's basically class. Okay. In general, ADT is viewed as class without inheritance. Okay. The second design issue is, can abstract data types be parameterized? Okay, what's the meaning of parameterized? Do you guys remember generic methods? So when you define a function, you can pass different type of values to it. Okay, in other words, when you define a method, you want to be able to use some type parameters, right? And for abstract data type, that's similar. In other words, if I want to define a stack class, can I use some parameters? Okay, that's type parameters. In other words, if I define a stack class, can I create a stack for integers, or stack for strings, or stack for students? Okay, so that's parameterized ADT. Okay, in C++, that's basically class template. It's pretty much similar to function template. So here is an example of class template. So in here, template is the keyword. So in here, template is the keyword. Okay, and in here, this tab name, that's also keyword. So T, just like in the function template, it's a tab parameter. Okay, so in this case, we only have one tab parameter, and then followed by class stack. So basically, we define a class template stack. Okay, T is the only tab parameter, and since T represents a data type, then it can be used as a regular data type within the class template. So in here, I think, sorry, I think there's typo. This should be T. Okay, similarly in here. Okay, so you can define a pointer to T. Okay, you can read the method can return a T, or can take a value of T as a parameter. Okay, so this is class template. Then if you try to create an object of different types, you need to provide a value for each type parameter specified in here. Okay, so in here, when I create a stack, then I provide int value for T. So that means I try to create a stack of integers. Okay, and you can also pass a string to T. That means you try to create a stack of string objects. And for here, I use student. That means I try to create a stack of student. Okay, and no matter which stack you created, you can always use this set of interface. You can call any of these operations to manipulate the stack. Okay, so this is class template in C++, and in Java, it's generic class. Okay, that's similar to generic methods we discussed before. And here is a generic method in Java. So here, this is used to specify the type parameter. So in here, type parameter is E. Okay, so E is viewed as a regular type within the generic box. So you can define a variable or member data of it, E, or you can pass a value of E as a parameter, or you can get a value of E from a function. Okay, and in here, it's similar to the usage of class template in C++. Okay, so you need to specify the value for the type parameter explicitly. enclosed by a pair of angle brackets. So let's create a generic box of string. Okay, so you can use these methods. Okay, you can also create a generic box of integer. Then you need to push integer to the generic box, and you can get integers out and output it, or you can create a generic box of double. Okay, so that's why the output is a string, an integer, or a double. Okay, so this is generic class in Java. Similar to the generic method in Java, the generic class also have something special. So generic parameters or type parameters must be class. It cannot be some built-in types like int, double, or float. No, they must be class. Okay. Restriction on generic parameters can be specified, like children of a class. So you probably can define something, let's say public class, generic box, let's say okay. So you can specify some restrictions. This means E must be a subclass or child class of this existing class. Okay. So this is a parameterized abstract data type. The next design issue is what access control are provided. Okay. So in here, typically there are 3 different types of access controls. So that's public, private, and protected. So for the public method or public member data, basically that means it's open to the world. That means everybody can access this public method or public member data. Okay. For the private, that means only the class itself can access it. Nobody else can access them. Okay, that's private. For the protected, it basically means only the class and its children can access it. Okay, and nobody else can access it. So for example, let's say, let me give you an example. So let's say we define 3 methods. One is public, one is private, and one is protected. Okay, let's say if we are in, let's say just okay. So let's say if you are in the method of some other class, or in other words, outside of the scope of parent class. So if you create an object of parent, can you call this one? This is fine because f is a public method, so it's open to the public. Everybody can access it. Okay, can you call this one? This will be arrow. Similarly, this one. That's because G is private and H is protected. So only, well, the general public cannot access them. Okay? And of course, within the class, so for example, this is fine because you are in the scope of parent class. So you can call private function. Okay? You can also call the protected method. Okay? But let's say if we define a child class inherited from parent, let's say we have, it doesn't matter what's the access modifier. Okay, can we call function f? Let me skip the inheritance. Okay, let's say p. Can we call this function? Well, this is fine because f is a public function, right? So everybody can access it, including the child of the class parent. Can we access function g in here? G is private. That means only parent class can access G. Okay, so its child cannot access it. How about H? H is fine because H is a protected method. That means the child class can access H. So this is fine. Okay, so in other words, ADT provides 3 interfaces. The public interface, that means it's for everybody. Private interface, that's only for the class itself. And the protected interface, that means for the class itself and its children, but it's not for the general public. Okay, so pay attention. There are 3 different sides of interfaces provided by each class. Okay, so in here, let's take a look at the access control provided in most program languages. Okay, so in C++. Okay, so C++ provide public, protected, and private. And C++ also allows you to define friend. Okay, so for friend, well, if you define a method or class as a friend of class, that means the friend can access everything you defined in the class. Okay, so in other words, friend and the class itself, they have the same power. Okay, so remember, so we don't recommend you use friend unless you have some really good reason. Okay, and you cannot do it without using friend. Okay, why? Because friend violates the information hiding principle. Okay, so this is C++ by default. It is private. Okay, so if you define a class, for example A, and you do not specify anything for this method, so it's F, public, protected, or private. So if a method or member data is not in the scope of any access modifiers, then it's private. Okay. In C++, it's quite flexible. the constructors and destructors, they can be public, protected, or private. Okay, so if a constructor is public, then everybody can use it. If all constructors are private, then users cannot create the object of the class. Okay, typically in this case, the class should provide a static method to create the object of the type. Okay, so this is in C++. In Java, Java also provide public, protected, and private scope. So public, protected, and private are similar, but here is a little bit difference. Let me first introduce package. So Java organizes the classes in terms of package. So a package is a collection of related classes and interfaces. Okay. So for public, that's similar. Everybody can access it. For the protected, that means it's class, it's children, and class in the package can access it. If it's private, then only the class itself can access it. Okay. By default, if you do not specify any access specifier for method or memory data, by default, only the class itself and all the classes in the package can access it. So this is a little bit different from C++. Okay. So for example, so typically, this is the way to specify the access control. You must specify it for each individual method. It's different from C++. Okay, so this one, you do not specify any public, protected, or private, then we use default. In other words, only the class itself and all the classes in the same package can access it. And this one, it's everybody can access it. And for this one, that means the subclasses and all the class in the package can access them. Okay, so this is Java. Okay. We can take a look at C#. C# is similar. You have public, protected, and private. In here, let's first introduce the concept of assembly. So assembly is basically the fundamental units of deployment or version control or reuse or activation scoping. So assembly is basically a connection of tabs and resources that work together, okay, and form a logical unit of functionality. Typically, assembly is either executable file or a dynamic linked library. Okay, so let's come back. The public, protected, private, they are pretty much the same as the one we have seen in C++. But C# provides some extra access controls. Okay, internal, that's only for class itself plus all the tabs defined in the same assembly. Okay, so that's for the internal. Protected, internal. This basically is protected plus internal. In other words, who can access it? So it's class itself, subclasses, and all the classes in the same assembly. Okay, and you also have private, protected. Okay, so in this case it's class, subclass, and subclasses from the assembly. Okay, if you do not specify any access specifiers, then by default it's private. Okay, so this is C#. Ruby is a little bit different. In Ruby, all member data are private. Okay, no flexibility. So this is used to enforce the information hiding, okay, or encapsulation. So all member data are private, and access control can only be applied to methods. Okay, can only be applied to methods. So it can be public, private, or protected. These are similar to C++. By default, all methods are public. Okay, so if you want to define a private or protected methods, you must specify it explicitly. Okay, so this is access control. I think the last design issue is the specification of the tab physically separate from its implementation. Okay. Well, we want to separate the specification from the implementation. It's as a user of that class, we don't need to know its implementation. We only need to know the specification, which contains the name of the class as well as the signature of operations it provides. Okay, and in most program languages, for example, like Java, C#, or Ruby, we do not separate one from the other. Everything is put in one unit, in one file. Okay, and in C++, it's not enforced, but traditionally you put specification in .h file and implementation in .cpp file. Okay, but it's not enforced by the language. It's more like program style. Okay, if you want, you can put everything in the .h file. Okay. And I think in the lecture notes, there's a solid object design principles. You can take a look. Okay, I think it's very useful, but I'm not going to cover it in this video. Okay, I think this is all.